Hello everyone. Today we are going to discuss how to solve this electric circuit to find the node voltages using nodal analysis. So to start with this, first we need to make sure that we have a ground. So this is the first step. So we can see that the ground is defined and the ground itself has a 0 volt. Then after that we need to identify the other nodes. So we can see here that we have, this is a node. Let's say it's node 1. Then we have another node here, 2. Then we have here a third node. Then we have a fourth, basically this node. Then we need to identify the voltage on each node. Okay, so let's say that this is V1. This is going to be V2, V3, V4. After that, we see here that we have actually some voltage power supplies. And from the voltage power supply, we need to see whether we have a super node or not. Okay, so we can see that whenever you see two nodes and in between there is a voltage power supply, that means we can create a super node. So we can say that actually that the combination of node number 3 and node 4 could be a super node. Okay, and knowing a super node, we can get two information. Okay, and we will talk about this later, while we can see also there's another super node here. So we can combine basically this one here. So all of this is another super node. So we have actually a super node 1 and a super node 2. So now from each super node, okay, we can see that each supernode can provide me with two equations. The first equation, let's talk about supernode 1. So we can see that supernode 1, let's say that this is a positive terminal. So we can say that this is positive, this is negative. So the potential difference here between V1 and V2 is 20 volts. So we can say that actually that V1 minus V2 is equal to 20 volt. So this is one equation that we can find here, first equation. Then from the same node we can do the KCL. KCL at supernode 1. And as we know, KCL says sigma I input is equal to sigma I out. So here we need to define some currents moving inside this circuit. So let's say that we have here I1, we have here 10 amperes goes up. Then basically we can say that we have here current I2, we have here I3, then we have here basically inside this branch we have I4. Then basically let's say that we are having here I5. So we can see that I1 is going inside supernode 1, and basically 10 amperes also going inside. I2 and I5 they are going outside. So we can say that I1 plus 10 amperes is equal to I2 plus I5. And as we know, once we have the equation that in terms of currents, we have to substitute using Ohm's law. And Ohm's law says, as we know here, that Ohm's law says the current itself is equal to the potential difference across the resistance over the resistance value. So I1 itself, basically you can see it's going up, so that means the higher potential is lower and the bottom side, and the high potential is up. So we can say, for example, it is 0 minus V1 over 2. So we can replace I1 by 0 minus V1 over 2 ohms. And this is plus 10. And this is equal to I2. I2 here, it goes from V2 to V3. So basically it's V2 minus V3 over the resistance 6 ohms, and this is plus I5, and we see I5 basically it goes it's basically the potential difference here, and we can actually replace it by Vx, and Vx also is equal to V1 minus V4 over 3 ohms. So we can say that actually it's Vx over the voltage difference over 3 ohms. Okay, and to remove the bottom part we need to multiply by 6 just to simplify it and make it more clean. So that means basically 6 over 2 is 3, so it's minus 3V1 plus 60 equal to V2 minus V3. And let's actually substitute Vx. Vx in this case is going to be V1 minus V4, V1 minus V4. I'm basically multiplying by 6 over 3, that means 2, so it's going to be plus 2 multiplied Vx, which is V1 minus V4. Okay, so let's organize this equation to be more clean. So you can see here, for example, it is 2V1, we bring this section to the other side. So basically it becomes 2 plus 3, it's 5 V1, and basically plus V2 minus V3 minus 2V4. All of this is going to equal to 60. So this would be our second equation. So let's talk about basically the supernode 2. So for the supernode 2, we can see that V3 minus V4 is equal to 3Vx. And we know that Vx itself is V1 minus V4, so we can say that it's actually 3 multiplied by V1 minus V4. So basically it tells us that 3V1 minus V3, bringing this one to the other side. So minus V3, minus V3, and bring this one as well to the other side. So it becomes plus, minus, so it becomes minus 2V4 equal to 0. So 3V1 minus V3 plus V4 minus 3V4, so it's minus 2V4. So you can see that this is actually the third equation that we have here. The third equation. Then the fourth equation, basically we need to do KCL at supernode 2. So as we said, sigma in is equal to sigma I out. So from here we can see that I2 and I5, I2 plus I5 is equal to I3 plus I4. So let's substitute with Ohm's law. I2 itself is equal to V2 minus V3 over 6 plus I5. I5 here is basically V1 minus V4 over 3, and this is equal to I3 is V3 minus 0 over V3 minus 0 over 4, and finally I4, and this is plus basically V4 over 1. So for this one, we need to remove the bottom part, so we can multiply by 12. So basically, if you multiply it by 12, this is going to be here. This is going to be basically 12 over 6, so it's 2, so it's 2V2 minus 2v3 plus 12 over 3, so it's 4 v1 minus 4 v4, and this is equal to 12 over 4, so it's 3, so 3 v3 plus 12 v4. So let's clean this one, so it is 4 v1, ended this part, let's sum all the 2, so it is plus 2 v2, then minus 2, and bring this one to the other side, so minus 2, this is minus 5. Okay, then basically we have this one, so it's minus 4 minus 12, so it's minus 16 v4 equal to 0. So basically this is going to be our fourth equation. So we can see that we have 4 equations of 4 variables. So it's kind of a bit tricky to solve these equations together. But let's do this step by step. Okay. So now we have 4 equations that we need to solve them to find the voltage or all the voltages. So the idea or the goal here is basically to go from 4 equations, basically to try to find 3 equations that you can solve them together with 3 variables. And to solve 3 equations with 3 variables, you need to find, basically substitute them together to find 2 equations of 2 variables to solve them together, so that you can find 1 equation of 1 variable to find the value of this 1 variable, then go back in the equation that has 2 variables to find the second one, then go to the third one to find the third variable, then go to the fourth one. So let's do this now, and we have to look on the equations to find exactly what is the best way to do this. So the goal now is to change these 4 equations into 4 variables to 3 equations of 3 variables. So I'm going to use equation number 1, basically, which says basically that V2 is equal to V1 minus 20. Okay. So I would like to substitute with this an equation, and let's say this one is equation basically number 5, and let's basically substitute this in equation number 2. So equation number 5 and 2, we can see that we have now 5 V1 plus V2, which is V1 minus 20, then basically minus V3 minus 2 V4 equals 60. Then basically this becomes 6 V1 minus V3 minus 2 V4, and let's bring the 20 to the other side, so it becomes 80. So basically this becomes a new equation, which let's say this one is equation number 6. Then basically let's substitute equation number 5 and equation number 4, sorry. So equation number 4. So we can see that here we have 4 V1 plus 2 V2. So we have 2 multiplied by V1 minus 20 minus 5 V3 minus 16 V4 equal to 0. So basically this becomes 6 V1 minus 5 V3 minus 16 V4 equal to, basically this is going to be 2 multiplied by 20, so it's 40, go to the other side, so it becomes 40. And this is going to be equation number 7. Then we can see that here we have 3 equations now to work with. Equation number 3, 6, and 7. This is of V1, V3, V4. Okay. Now we would like to reduce these 3 equations into 2 equations in terms of V3 and V4. Okay. Try now the following. So we can see that we can subtract equation number 6, okay, minus equation number 7. So we can see that 6v1 minus 6v1 is 0. Then we have minus 1 minus minus 5, so it's plus 5. So minus 1 plus 5 is 4. So 4v3. Okay, then we have minus 2 minus minus is plus, so minus 2 plus 16. It is basically plus 14 v4. Then this is equal to 80 minus 40. It's 40. So we can see that we have this, and basically we can use this equation. So let's call this one equation number 8. Let's do the following. So let's take equation number 6, and we say it's minus 2 multiplied by equation number 3. Okay, so basically this is going to be 6 minus 2 multiplied by 3, so v1 is going to go. Then basically we have minus v. Let's do it this way. So to solve this one, basically we have 6v1 minus v3 minus 2v4. Okay, then basically let's subtract 2 multiplied by the equation number 3, the left side. So basically it's 3v1 minus v3 minus 2v4. Okay, this is equal to, let's go for the right side. The right side of equation number 6, it's 80, and the right side of equation number 3 is 0, so it's minus 0. So we can see here basically that it is 6. That's basic 6. Let's write it again, or like in a better way. v3 minus 2v4 minus 6v1 minus 2v3 plus 2 multiplied by 2, so it's 4v4. All of this equal to 80. So it's 6. Sorry, this is minus 2 multiplied, so it's minus, so this is plus 2v3 plus 4v4. We can see that 6 goes to minus 6. So we can see that's 2 minus 1, so it is v3. And basically 4 minus 2, so it's plus 2v4. And this is basically equal to 80. And this is going to be equation number 9. And right now we have many equations, but we are about to solve them. So from here, we can see that we can solve equation number 8. So now equation number 8 minus 4 multiplied by equation number 9. So this basically becomes 4v3 plus 14v4, okay, minus 4v3 minus 4 by 2, so it's 8v4. This is equal to 40, and this is basically minus 4 by 80. So the 320. So basically this one goes with this one. So that means we have 6v4 equal to minus 280. That means basically that v4 is equal to minus 46.67 volt. So this is v4. And from v4, so let's substitute in equation 9. We can see the following, that V3 is equal to 80 minus 2V4, 2 multiplied by V4, which is minus 46.67. So that basically means that V3 is equal to 173.34 volt. So this is V3. Then we have V3 and V4. Basically, we can, let's see, for example, V3 and V4. So, for example, we can substitute in equation 6. So, let's say, for example, here. So, substitute in equation 6. And equation 6 says what? 6 V1 minus V3. V3 basically it is 173.34 minus 2V4, and V4 is equal to minus 46.67. All of this is equal to 80. So from here we can see that 6 V1 is equal to 160, which means that V1 is equal to 26.67 volt. So we have this one. Let's go to equation number 5. So let's basically substitute in equation 5. So equation 5 says that V2 is equal to V1 minus 20. So basically V2 is equal to 6.67 volt. So now we got V1, V2, V3, V4. So we started basically by 4 equations that we have to solve with 4 variables. Then we tried to find from the 4 equations, basically make some substitution to have 3 equations of 3 variables. Then basically from the 3 equations, 3 variables, we got 2 equations of 2 variables. Then from the 2 equations, 2 variables, we got 1 equation of 1 variable. Then we got V4. Then we went back to the equation of 2 variables to find V3. Then we went back to one of the equations of 3 variables to find V1. Then finally, we got the final value of the voltage. I hope you learned something from this example, which is using nodal analysis and having also super nodes inside. If you have a specific question that you would like me to answer, please write in the comments, and it would be my pleasure to solve it for you. Thank you so much and have a great day. Bye-bye.